Hey, welcome to Developer Roadmaps. You know, the world of DevOps can feel, well, a little all over the place, right? So today, we're going to change that. We're going to build a clear, step-by-step roadmap that shows you exactly how modern software gets built, scaled, and delivered with real speed and reliability. Let's dive in.
Okay, before we get into all the cool tools and technologies, let's tackle the big question right up front. What does a DevOps engineer actually do? It's one of those job titles that can feel a bit mysterious, but I promise, by the end of this, it's all going to make a lot more sense.
And here's the absolute key thing to get your head around. DevOps isn't just a job title. It's a mindset. It's really a whole culture built around breaking down those old walls between the people who write the code, the devs, and the people who make sure that code runs smoothly, the ops teams. The whole point? To ship better software, way faster, and without all the drama.
All right, here's the game plan for our journey today. We're going to cover what DevOps is, then build up from the foundation of code and systems. We'll move on to connecting our apps with containers and networks, then hit the cloud with infrastructure as code. And finally, we'll put the cherry on top with CI/CD automation. It all leads to you starting your own DevOps journey.
Okay, let's start at the beginning. Every great structure needs a solid foundation, right? For us, that's the ground floor of our roadmap, understanding the code and the systems that everything else is built on. So if you're gonna automate things, you've gotta speak the language of the machines. First up, you've got Python. People love it because it's so readable. It's almost like writing in plain English. This makes it perfect for whipping up scripts to handle all those boring, repetitive tasks. Then you have Go. Think of Go as the language of the cloud. So many of the tools you'll use, like Docker and Kubernetes, are built with it. It's compiled, which basically just means it's super fast and efficient, perfect for building those high-performance systems. Okay, so we've got our code, but where does it actually live and run? Well, take a look at this number. Over 96% of the world's top web servers run on Linux. That's pretty much everything. It's the silent, incredibly reliable workhorse powering the internet and the cloud. Getting comfortable with the Linux command line, knowing how to manage services, these aren't just nice-to-haves, they're fundamental. So let's place it on our roadmap. This is a critical checkpoint for any DevOps journey.
All right, foundation's in place, we have our code and our OS. Let's move up a layer on the roadmap. Now, it's all about how we package up that code and connect it to the rest of the world.
Oh boy, if you've been around development for any amount of time, you've heard this one. Maybe you've even said it yourself, but it works on my machine. This single phrase is the reason containerization exists. It's that nightmare scenario where code works perfectly on your laptop, but the second it hits a real server, it just breaks.
And Docker is the brilliant solution to that problem. The best way to think about it is like cooking. First, you have the Docker file. That's your recipe, a simple text file with all the instructions. When you build that recipe, you get an image. Think of this as a perfectly sealed prepackaged meal kit with every single ingredient included. Then, when you're ready to serve, you run that image and it becomes a container. That's your final, perfectly cooked meal. And the beauty is, it tastes exactly the same no matter whose kitchen you cook it in.
So your containers are up and running. Awesome. But how does traffic from the internet actually get to them? Well, that's where something like NGINX comes in. It's often called the Swiss Army knife of web servers, and for good reason. It acts like a traffic cop for your whole system. It stands at the front door, directing requests to the right container, and it's smart enough to spread the load so no single part of your app gets overwhelmed.
And you know, holding all of this together are a few core protocols that just make the internet work. You've got DNS, which is basically the internet's phone book. It turns a name you can remember, like google.com, into an IP address that computers can actually use. Then there's HTTP, that's the language browsers and servers use to talk to each other. And finally, SSH. Think of that as your super secure, secret tunnel for logging into your servers and managing things remotely.
Okay, so we've got these perfect self-contained applications. But where do we run them, especially when we need to run a lot of them, reliably? The answer, of course, is the cloud. But managing things at that scale requires a totally new way of thinking.
So here's the problem with the old way of doing things. Just clicking around in a web console to set up servers. It leads to this monster called configuration drift. What's that? It's when, over time, tiny manual changes pile up, and your production server becomes this one-of-a-kind, mysterious snowflake that nobody can reproduce. And trying to fix it when something goes wrong? Absolute nightmare.
The solution? It's a revolutionary idea called infrastructure as code, or IAC. The core concept is you stop treating your servers like pets,
each with a unique name that you care for by hand. Instead, you treat them like cattle, as a herd that you manage together. You define everything, your servers, your databases, your networks, all inside configuration files. That code becomes the single source of truth for what your environment should look like.
And the tool that pretty much everyone uses for this is Terraform. Its workflow is just beautiful. First, you write the code that describes the cloud infrastructure you want. Then, and this is the magic part, you run a plan. Terraform shows you exactly what it's going to create, change, or destroy before it does anything. If you like what you see, you give it the green light with apply, and it builds everything for you. It's safe, it's predictable, and it's repeatable.
Now, this brings up a really common point of confusion. What's the difference between a tool like Terraform and another one like Ansible? The house analogy is perfect here. Terraform is for provisioning. It builds the empty house, the servers, the network, the database. Ansible is for configuration. It's the tool that goes inside the house to furnish it, installing software, setting up users, and deploying your actual application. They're not fighting for the same job, they're partners.
All right, we've made it to the top of our roadmap. This is the capstone. We've got our code, we've got our containers, and we even have our infrastructure defined as code. Now it's time to glue it all together and automate, well, everything.
Just look at the night and day difference here. Before, a developer's life involved this long, stressful mental checklist every time they wanted to deploy code. You'd have to run the tests, build the project, log into a server, copy the files, and then just pray it worked. Now, with a tool like GitHub Actions, there's just one step. You push your code. That's it. The pipeline takes care of everything else.
And that is the magic of CI/CD. It stands for continuous integration and continuous deployment. It's really the ultimate goal here, automating every single step from the moment a developer commits their code all the way to it running in production. This is what lets elite teams release new features multiple times a day with total confidence, instead of just a few times a year with a whole lot of fear.
So let's step back and look at the map we've just created. We started with a solid foundation in code and systems. We learned how to package and connect our apps. Then we moved to the cloud, managing everything as code. And finally, we tied it all together with end-to-end automation. Your DevOps journey is about to begin.
Now, obviously, each one of these sections is a deep topic all on its own. But the point is, now you have the map. You can see how all these different pieces connect to form a modern, automated pipeline. The path forward is clear. So the only real question left is, what's the first checkpoint on your roadmap going to be?
This is Developer Roadmaps. Map your path, build your career.